No, ready, aim, fire. No, ready, fire, aim. I like better because it's kind of a joke. I mean, it's getting the order mixed up, but that's the joke. That's yeah, ready, fire, aim. So w squared minus 49 is a quadratic equation, and up till now, what we've done in terms of solving this is we factored it. That's w minus 7 times w plus 7 equals 0, and that's fine. Hopefully you can read off the two solutions. This or this has to be 0 because it's part of a product that equals 0. So either w equals 7, making this 0, or w equals negative 7. So no big deal. Now, a lot of you guys have been chomping at the bit to say, well, wait a minute. Couldn't we also solve that by using the square root? So, yeah, let's take a look at it a different way. That is, w squared minus 49 equals 0. So I'll move the 49 to the other side. If it changes sides, it changes signs. So, great. And what a lot of people have been anxious to do is just say, all right, well, let's take the square root of both sides. And unless you're careful, you're only going to get one solution here. Over here, I got two solutions. Now, the workaround is that when you take the square root here, make sure you take plus or minus the square root. So now I've got two solutions that represents both of my solutions to this quadratic equation. Not bad. This actually works in general, that you can take the square root of both sides, and when you're trying to get your solution, make sure you take plus or minus the square root on the right-hand side. So that way you got both solutions. It's a quadratic equation, so it typically has two solutions. Now, this idea of the square root property works in general. Even if I didn't have nice numbers, like here. W squared equals 47. If I take the square root of both sides, I get w is plus or minus the square root of 47. Now, realistically, what this means is that w equals the square root of 47, or w equals negative the square root of 47. Now, there's nothing in here that's going to simplify. 47 is a prime number, so it's not like 72 that you could break it up into the square root of 36 times the square root of 2. There's nothing that's going to simplify, so we'll just leave it like this. Typically with these problems, I'm not looking for decimal answers. I want an answer that includes square roots, or it's just going to be whole numbers or fractions, but not decimal answers. We'll get there. Yeah, it's a good question. If it's a negative on the other side, we will get there. And fortunately, we have the math behind us that we can cover that now. How about something like this? M squared plus 75 equals 76. So what I've done to choose these problems is I went through Newton and picked out problems directly from them. So that way, this lecture is very much like the problems you're going to get working with Newton. What would you do for this one? Good. Subtract 75 from both sides. So 75 from 76 is going to give me a 1. So m is plus or minus the square root of 1. Boy, if you leave it as the square root of 1, I'll probably be unhappy. What's the square root of 1? 1. Yeah. Please make sure you simplify that down to plus or minus 1. Building on our success from that previous problem, let's take a look at z squared minus, or 7z squared minus 10 equals negative 3. So a little bit more involved on this one. I'm open for suggestions. What would you do to work on this one? All right, let's add 10 to each side. So if I add 10 to each side, I get 7z squared equals 7. All right, good. Someone else for a suggestion. Now what? Yeah, let's divide both sides by 7. So divide by 7 on both of these. And I get z squared equals 1. And we're kind of back to something similar to the previous problem, right? z equals plus or minus the square root of 1, or basically plus or minus 1. Okay, so far so good, I hope. But if there's something about this previous problem or this problem that I went over a little too fast, let me know. Mm-hmm. If there's a perfect square underneath your square root, then I'd want it simplified. So if you had, let's do plus or minus the square root of 50. Plus or minus the square root of 50, I want that broken up as the square root of 25 times the square root of 2, which of course part of that will simplify. Now 47 didn't have any perfect squares as part of it, so yeah, there's nothing, there's no perfect square that evenly goes into 47. In fact, 47 is prime, so the only factors of 47 are 1 and 47. So thanks for the question, Ricky. Anything else on this first page here so far? Well, let's keep going then. Let's try 6u squared minus 220 equals negative 196. Why don't you try this one? This one should work out pretty even, so work your way through it. That's the digital pause. Yeah, I saw that one. That's my high-tech pause button. All right. There we go. So I didn't get to everybody, but my quick sample, everyone's jamming on this problem, looking pretty good. So of course, start by adding 220 to both sides. That gives me 6u squared equals 24. Divide by 6, u squared equals 4. So u is going to be plus or minus the square root of that. Plus or minus the square root of 4 is plus or minus 2. So, nice. Worked out pretty even. Let's try another one. And Elise, this is getting to your question just a minute ago. 3q squared equals negative 3. Work me through this one. What would you do first? Divide by 3. Q squared equals negative 1. So q would be plus or minus the square root of negative 1. Someone help me out here. What's the square root of negative 1? Don't say narn. I. So you get plus or minus I. So that's your solution. So that's the answer to your question. James?
It's probably simple, but you got I wouldn't it always be positive because if it was negative, it would be like.
No, both of these actually. Well, so I guess your question is, if I had negative I, doesn't that simplify to just 1? So it's a good question. Let's keep in mind that I is really the square root of negative 1, but that negative doesn't factor itself inside here. It doesn't cancel with that and make it a positive 1. So, because you have to do the root part first, which prevents you from doing that distributing, canceling. All right? Yeah, it's a good question, and it's a natural tendency, so thanks for asking that. Let's try another one similar to that one. Are you up for trying this next one? I'll take that as a yes. Good job. Thank you. Yeah. Let me tell you in Spanish. No. We. All right. So, what would you do to start on this one? Subtract 121. Hopefully you notice that 121 is, I don't know, 11 squared. Just throwing that out there. N squared equals negative 121. And keep going. See if you can't simplify this. Here comes my high-tech pause again. Remember, we got deal with the negative because we've got I, and you deal with the square root of 121, deal with the square root of 9. So all of those should work out pretty nice. Oh, isn't that special? Wow, another press. Okay, keep going. All right, probably don't want to work with this one. Just keep working with the fractions. Hopefully you recognize that 121 is a nice even number as far as square roots. I divide both sides by 9. Yes. Okay. So write it as a fraction. Don't write the decimal. Write it as a fraction. Because writing it as a fraction, you'll be able to actually simplify it. Looks like you kind of did that over here. Except square root of 9 is 3. You should get rid of the square root. There should be no square root here. You're far from the only person that ever does it. I get that a lot. So yeah, that looks good. Just those are plus or minus there. Okay. Then we divided by 9. So you should have 9 there. That 9 should be in the denominator of radical. This is for a few people. There's 13 people that didn't pick up their exam. So, you know, wow.
Did you happen to pick it up, or did you put it on?
Well, it's not on noon. It's beyond D2L. But it's still there, and I did pass it out. So if you came in a little bit late, I can get it to you after class. Okay, so divide both sides by 9. N squared is negative 121 over 9. Then what's been our habit at this point? Take the square root, right? So n equals plus or minus the square root of negative 121 over 9. If you want to, if it helps you out, you can break that up into like 3 different radicals. There's a square root of 121, there's a square root of negative 1, and the square root of 9. You can do that because this is all division or multiplication in the case of the negative 1 times 121. You couldn't break this up if there was an addition or subtraction in there. But we're okay. How does this all simplify? Plus or minus 1 at a time. 11 I 3. Good. Remember the idea was to make me look good, right? Thank you. Corbin?
I did something different. You already look good. So.
Oh, this is true.
I did something different, but I got the same answer. So I just squared both sides of the equation, and then divided by 3 on both sides.
If you take the square root right here, it's wrong. You You can't take the
No,
square
not
root.
right there. I moved the 121 over to the other side.
Oh, you took the square root here?
Yeah.
Oh, that's fine. If you take the square root there, then you're going to get 3n is plus or minus, 11i, and then divide by 3. So, yeah, that works. Nothing wrong with that. Yeah. There's nothing wrong with um, moving this over and then taking the square root here. I guess I just like isolating the variable first, but I'm not going to complain. If I can follow your work, that's fine. The one thing that I don't want, though, is you can't take the square root of both sides here, because in doing that, you'll be stuck. If you say, oh, okay, well, square root of this, 9n squared plus 121 equals square root of 0, you can't go anywhere with this. You can't break this up as a square root of 9n squared plus a square root of 21. It just doesn't work. And in general, square root of a plus b does not equal the square root of a plus the square root of b. You can't distribute that square root. So don't do it. Good job. Let's keep going. Do you think I can apply the square root property to do something like this? X minus 1 squared equals, let's do 16. Sure. You have to be a little bit careful, but yes. So let me actually show it out. Square root of x minus 1 squared, and on the right hand side, plus or minus a square root of 16. So that's x minus 1 equals plus or minus 4. Here's where you just got to slow it down just a little bit. I know it's tempting. I know you want to just move that 1 to the other side and go, oh, plus or minus 5. Doesn't quite work that way. So what can we do? Well, there's two possibilities represented by this plus or minus. It's either x minus 1 equals 4 or x minus 1 equals negative 4. To solve, I'm just going to add 1 to both sides. On the one hand, I get x equals 5. What do I get on the other hand? Thank you, negative 3. So what you can't do is just move the 1 to the other side and go, oh, plus or minus 5 and declare victory. Yeah, it doesn't work that way. But, it's not that hard. All you have to do is just take a little bit of time and finish it off carefully. So how's that one looking? Okay there? All right. Let me give you one similar to that. Is there any misgivings or anything on this one while I have it up before I move on to another one? Yeah, please. I'm not sure where I see a place to distribute the negative.
I guess the last problem, because there was like x in front of the variable squared, and then what was the problem? You said x minus 1
Squared.
squared.
Right.
And so when I see it arranged that way, I automatically think, oh, maybe distribute negative and everything positive.
I don't see a negative that I would distribute. I mean, some people want to square this out and go x squared plus 1, but I don't see a negative that distributes itself because there's no negative here. The only negative is the negative 1.
So we don't need to distribute the negative when it's in the center, but we would if it were in front of the x.
If there was something in front of x, in fact, I do have one coming up that might get at your question or concern. So hang on to that for 2 more problems, and then we'll see something that hopefully will address your concern. And if not, then let me know. We'll work on it some more, okay? Thank you. X plus 5 squared minus 169 equals 0. So give that one a shot. Try and use the square root property like we've been practicing. I'll try and help out as well. Okay, so the natural step is to add 169 to both sides. X plus 5 squared equals 169. Take the square root on both sides. On the right-hand side, make sure you take that plus or minus. So you get x plus 5 equals plus or minus 13. And I'm just going to take my time and do both possible cases. So the positive case is x plus 5 equals 13, and the negative case is x plus 5 equals negative 13. So the positive and negative cases. If I subtract 5 from both sides, I end up with x equals 8 or x equals negative 18. So there's my two solutions. How can I check those if I wanted to? If I looked at that and said, yeah, I'm not so sure, I'm feeling uncomfortable with that, how can I check it? Yeah, plug them back in. So negative 18 plus 5 is negative 13. Negative 13 squared is 169. 169 minus 169 is 0. And likewise, 8 would also work as a solution. So it checks. Good? Okay. Ricky, let's see if we get to your question, if we somehow answer your question in this one. So, same kind of problem as the last one, just a little bit more involved because of some of the negative signs. So, negative 2q minus 3 squared equals negative 4. Can we go anywhere on this one? What should we do? All right, thank you, James. Take the square root both sides. Square root of negative 2q minus 3 squared equals plus or minus the square root of negative 4. So take the square root on both sides. Great. Now on the right-hand side, whenever you have a negative underneath the radical, what did I suggest you do? What was the first thing I suggest you do? Yep, split out that negative 1 so you can convert it to an I. So what we end up with is plus or minus 2I. How about on the left-hand side? How does the left-hand side simplify?
Start moving the 3 over, and then as soon as the 2q is along, then we go ahead and do our plus and minus scenario to get two different answers.
Okay. So first things first, what Ricky's kind of hinting at is that when we take the square root of this thing squared, these two operations cancel each other out. So square root and something to the second power cancel. So on the left-hand side here, I'll be left with 2q minus 3. Okay. So we've got two cases, really. You've got minus 2q minus 3 equals plus 2I or minus 2I. And it's kind of up to you. There's really a couple ways you could work on this one. Let me just do out the positive case and negative case as before. Negative 2q minus 3 equals 2I. Negative 2q minus 3 equals negative 2I. I need to solve for q in both of these. So I think, Ricky, you were saying add 3 to both sides. So it's 3 plus 2I. Now keep in mind, these aren't like terms, are they? 3 plus 2I, can't combine that and get 5I, for instance, or 5. It's just 3 plus 2I. And what's the last thing here? Divide by negative 2. So I'll get q equals 3 plus 2I over negative 2. Leave yourself some space here. I got to tweak that a little bit. And then over here, likewise, I get negative 2q equals 3 minus 2I, or q equals 3 minus 2I over negative 2. Now, it's probably a little bit informal, but I'll let you get away with this on an exam. my hunch is that Newton might not like it. Newton's probably going to want things in the form of A plus BI. So if that's the case, it would be 3 divided by negative 2. Let me just write that like this. 2i over negative 2. Well, let's think. 2 over 2 is going to cancel to 1. And then a positive divided by negative is negative. Yeah, so negative 3 halves minus I, or minus 1i if you need to. And in a similar way, this is going to simplify. So let me maybe show out the details here. It's 3 over negative 2 minus 2i over negative 2. So you're just dividing each term in the numerator by that term in the denominator. There's no simplification here. I'm just going to write the negative out in front. Negative divided by negative is positive, and then the 2's cancel. So a little bit more detail there than I showed over here.
So if you're multiplying 2 and 2i, you can't get 4i, but if you're dividing them, you can cancel the numbers out.
Say again? So if I'm multiplying,
Here we determine that like you can't combine 3 minus 2i.
yeah, because these aren't like terms, because the one doesn't have an I and the one does have an I.
If they're not like that, how do we simplify them if they go over each other?
Well, you're dividing. Okay, so,
Could I multiply 3 and 2i together?
yeah, you could multiply 3 times 2i and get 6i. Yeah,
Subtract them.
yeah, you can't add or subtract them. So you can multiply or divide them, but you can't subtract them or add them. Do you want one more like this? I mean, it's just kind of like broccoli. You know it's good for you, but you may not really like it. So it's your choice. Want one more? All right. By the way, Ricky, did we answer your question about the negatives, distributing the negatives on the last one? Okay, good. 3z minus 8 squared equals negative 25. Okay, so as with a lot of these things, we're going to take the square root of both sides. So on the left-hand side, that's going to be 3z minus 8. The right-hand side is going to simplify down to 5i. So plus or minus 5i on the right-hand side. And that's just a matter of finishing the solution here. You've got two cases, a positive case and a negative case. 3z minus 8 equals 5i, or 3z minus 8 equals negative 5i. In either case, you're going to add 8 to both sides. So I end up with 3z equals 8 plus 5i, or 3z equals 8 minus 5i. Dividing by 3 finishes things up as far as I'm concerned, but it might not work for Newton. You might have to go the additional step of writing that as 8 over 3 plus 5 over 3 times I, and then likewise 8 over 3 minus 5 over 3 times I. You can put the I next to it or up in the numerator. Oh, yeah, thank you. I, yes. Yeah, I need the I there. No, it's all right. No, I want my videos to look good, so thank you. All right.
So we don't know if it's going to ask if 8 equals 5 divided by 3 is 5.
My guess is you're going to need this. Yeah. So, but on an exam, this is fine. One thing that you've been lucky with so far is that you've been given things in this form. You've had this nice perfect square. It's just begging for the square root property. But quite often you don't get that. Quite often you have to do a process called completing the square. So unless there's some more questions on this, let's finish up section 10.1 work with completing the square. Completing the square. Well, what do I mean by that? Well, let me show you kind of in the reverse direction what we're going to end up doing. Suppose you had x plus 5 squared. Hopefully you realize that that's not x squared plus 25. To figure this out, we'd probably multiply the binomial by itself and get something like this. X squared plus 5x plus 5x again plus 25. And that simplifies down to this. X squared plus 10x plus 25. So, okay. I mean, nothing terribly exciting there, I don't think. We know that these two things are the same. But here's what things are going to look like for problems in this section. You're going to be given something like x squared plus 10x plus something equals something squared. And what we're going to have to do is figure out, all right, well, what do I square, or what do I put here so that this can be written as a perfect square? It can be written as something in a binomial squared. Well, our answer in this case is 25. Where did the 25 come from? Yeah. So 5 times 5, or better yet, 5 squared. Somehow or another, you're going to need to realize I need to put a 25 there, which is our 5 squared. How am I going to figure out a 25 by looking at a 10? Where's the 5 going to come from? All right, it's the 5x plus the 5x. That's where I get the 10x. So if I kind of divide that by 2, then I would get the 5 that I want, right? So divide this by 2 and then square it. So those are the two steps that I need here. Now I'm going to state it a little bit differently. I'm going to say multiply this by 1/2, but that's the same thing as dividing it by 2. It's just that in some cases it's going to be easier to multiply by 1/2. So hang on to that. Yeah, please.
Because you were like right on the edge of saying what you just said, and I was thinking maybe how we reverse engineer that.
Yes.
Okay, what happens in the case of, let's say, for instance, you have an x squared plus 7x plus.
Still the same thing. Still divide by 2 and square it. Yep. It's the same instruction. So what's going to happen is that we're going to start out with a couple of easy examples of doing this and then work towards the harder ones. And one of the harder ones would be the one that you suggested. So to complete the square, complete the square on x squared plus bx, here's your steps. So you have x squared plus bx plus something is something squared. The first step is to multiply the middle coefficient by 1/2. So multiply the middle number by 1/2, and that is 1/2 times b. The second step is to square the result from 1. Square the result from the first step, and that is 1/2 b squared. Those are the two numbers that you're going to need in order to complete the square. So the first one, the second one of these is going to go right here. That's what happens to that one. And then the other one is going to help us with the factorization here. So let's see a nice friendly example of this to start with. Y squared minus 20y plus something is something squared. So the first step is to take 1/2 times the middle coefficient. What's the middle coefficient in this case? Negative 20. Thank you for giving me the negative as part of it as well. So that gives me negative 10. The second step is to take that negative 10 and square it. So what do I get when I square negative 10? 100. Thank you. In unison. I want to point that out for my viewing audience. Yeah, they're all really engaged and in tune. That's good. So now let's take these two numbers here and finish completing the square. This number comes here. So it's y squared minus 20y plus 100 equals, and then this number is going to help me out here. It's going to be y minus 10. And there you go. So you've completed the square. You're looking to fill in exactly this information. It's exactly the way I'm going to write it on an exam. Okay, how are we looking with that first one? Pretty good? Love it? Oh, the crowd is going wild. I wish you guys could see that. All right, maybe I could turn the camera. What do you think? I'm recording this for YouTube. So, yes. So make sure you make me look good. That's the rule of thumb. I doubt the microphone is that sensitive that it could pick you up. It's probably like, the old Charlie Brown, sitcom or stuff. Wah, 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 is what you hear in the background. What's that? The only thing you're going to be able to see is what you're seeing here. Yeah. So it's not showing my face or any of your faces. Yeah. You got my cool little M logo here today. That's good. All right. So let's try. This is true. x squared plus 12x plus something is something squared. So the same kind of two steps with this problem that we had with the last problem. Start out by taking half of the middle coefficient. In this case, half of what? Half of 12. Half of 12 is 6, and 6 squared is 36. So, okay, nice. See if you can't finish this one up. Okay, where's the 36 go? Good, so that's going to be 36 there. Perfect. And this goes in here, so x plus 6. Bingo. Nice. Chris?
Just out of curiosity, because I want to see this, I guess. Are you ever going to see one that would be, for instance, x squared plus 12x minus blank instead of plus blank?
Well, one thing I will point out right here, especially since you're asking, but I was going to point out anyways, so thanks for reminding me, is this. There's a little similarity here between the signs. This sign and this sign are the same. This sign and this sign are the same. So the sign in front of your middle term and the sign in your binomial should always match. Always. And this one is always going to be positive. Why does it always have to be positive? Because it's going to be the result of a negative 10 times a negative 10 or a positive 6 times a positive 6. But you're squaring this, and when you square something, you're going to get something positive. So, yeah, correct. It wouldn't be a perfect square at that point. It'd still be a fine polynomial, but it just wouldn't be a perfect square. So this is called a perfect square trinomial because these three terms are the square of a binomial. So that's what it's called. Okay, just to keep you guys engaged, what we'll do is we'll make these harder. So, all right, so m squared plus, see that was a nice subtle segue. M squared plus 5/3 m plus something equals something squared. Now, if you think back to when I gave you the instructions, I was a little bit particular about how we said that. I didn't say divide this by 2. What did I say to figure out that, work on your middle term? Multiply by 1/2. And I guarantee you that 95% of you are going to be much more comfortable multiplying that by 1/2 than you are dividing by 2, even though it's the same thing. If there was some cancellation, you should do it. But there's not. What do I get when I multiply 5/3 by 1/2? 5/6. Okay. 5/6 squared. Can anyone square 5/6 without their calculator? Thank you. Making me look good. All right, I appreciate that. So 25 over 36. Perfect. And now what? Where do these terms go? What do I do with the 25 over 36? What do I do with the 5 over 6? All right, so that's 25 over 36 here. Good. Someone else. What's the rest of this? What goes here? Thank you. M plus 5 over 6. That is simplified. That's perfect. That's exactly what I want. By the way, I want fractions, not decimals here. Please don't give me decimals. I'm not happy with those. Yes. Yeah. Fractions are numbers too. So that's right.
So it's like when I get a fraction of my paycheck, I should
Yeah, I wish the government left me a bigger fraction of my paychecks. All right. Let's try another one. Now up here, I suggested that if there was some simplification, that you do it. Now, This example, we didn't get any, but try this one. Z squared minus 2/3 Z. I probably should have chose a different variable. Is something squared. Okay. Okay, looking good here. All right, very happy with what I'm seeing here. First step is take half of that middle coefficient, half of negative 2/3. One thing you could do, probably should do, is the little bit of cancellation you can right here, and that is, let's see here, let's do this one. The 2's cancel. It leaves me with negative 1/3 for my first step. And when I square negative 1/3, I get 1/9. Nice. Tay, help me finish this one up. What do I do with the 1/9? Where should that go? Good. So that'd be the 1/9 here. And then what goes here? Perfect. Z minus 1/3. You guys look like you're doing pretty good on that. Let me give you one last example. Kind of the only other thing that you might see from Newton that might trip you up a little bit, and that would be something like this. A squared minus 11a plus something equals something squared. So Chris, this is a lot like yours. Earlier you had a 7, I put an 11. All right, but this is the same kind of thing. The thing to keep in mind is that you're going to do the exact same thing here that you did with all the other ones. Start up by multiplying something by 1/2. What is it that gets multiplied by 1/2 in this case? Yeah, negative 11. If it helps you, you could think of that as negative 11 over 1. Maybe that helps you out with the multiplication. If it does, do it. No, no decimals. It's actually works out pretty nice because when I multiply this, maybe you can help me out. What's 1 times negative 11? Negative 11. 2 times 1? 2. So that wasn't bad. How about over here? How about over here? If I square negative 11, wait, come on. It's on the left-hand side board. You got 11 squared right there. 121. I tell you what, with your eyes closed, I think you can do the last one. What's 2 squared? Come on, give it to me. You're live, remember? All right, 4. Quattro, yeah. Fear in German. So, uh, so let's see. The 121 over 4 goes here. And then a minus 11 over 2 goes there. That's as hard as they're going to get on Newton. So I looked through a lot of homework problems, and that's as hard as they're going to get. So we're looking good on that one. Actually, yeah. Why don't you hang on to that for just a second? So when Julius Caesar was rumored to come up to a battlefield, and he surveyed it, and he looked, and he said, "Bini, bidi, bici." I came, I saw, I conquered. So I think we conquered this section. Well done. Give the homework a shot. Bini, bidi, bici. Yeah, kind of a cool little phrase there. All right, well done.